Hey, AP Statistics, we are going to finish up example 5, and in class we've already done the hypotheses and the conditions. So we're just going to continue on with the test statistic. So here we know the population standard deviation. You already have this hopefully highlighted in your notes. But since we know the population standard deviation, we are then going to be doing a z-test statistic. Okay, so this is definitely much more realistic versus like what we did with the confidence interval. So we take our x bar, which is 129.93, minus the population mean, what's in our hypotheses, divide by the standard deviation, okay, the populations of 15, divide by square root of n, and so our n is 72. Okay, so here is our random sample. So go ahead and stick all that in your calculator. I like to do that all in one step, but go ahead and do whatever you need to do. And you should get 1.092, depending on a little bit of rounding error. All right, so as we flip the page, the p-value is just saying how likely is it that we got a z-score of 1.092. So here we've got our normal curve. Oh, my pen is a little bit off. Here we go. We are at 1.092. So we're actually going to shade in quite a bit of the curve. Okay. So there's two ways you can write your probability notation. You can say probability our x bar was greater than our value of 129.93. But you can also, this is equivalent to writing the probability our z-score is greater than 1.092. I'm going to probably start using like z and t a lot once, especially once we start doing absolute values. It makes it a lot easier if you just use a z or a t. So you might see me start writing that quite a bit. Okay, so now I've got normal CDF. We're going from 1.092 to positive infinity. So go ahead and calculate that. You should get 0.137. Okay, so previously that's where we stopped and just said, okay, well, that's our probability. Well, now we have a conclusion. So we want to compare this p-value. If it's less than or equal to alpha, then we reject. Okay, so we're going to take 0.137 and our alpha level for this problem is, when we look back, is 0.01. So is that less than or equal to 0.01? No, it's not. So we are going to what's called fail to reject. 0.137 is larger. So we're saying that we could have got a value quite easily that's this far away. So when we look at our curve, we're saying that like our alpha level of 0.01 would only be like shaded over here on the right. But our p-value is more likely than that. So we're failing to reject. Okay, we are not agreeing with the null. We are just failing to reject the null. And what that means is if we took a different sample, we could end up rejecting it. So we never just really say we agree with it. We're just saying based on the data we have, we can't reject it. Okay, so our conclusion, what the sentence structure looks like is we're going to say, since our p-value here is greater than alpha, which equals 0.01, we are going to fail to reject the null hypothesis, okay, the HO, the HO, null, okay. So we have insufficient evidence, okay, or if you don't like that word, some students don't like that word, you can say we don't have enough evidence, it's the same thing. So whatever you want to write is fine. Evidence to suggest that the mean blood pressure level for all the company's young executives is greater than the national average of 128. Okay, so go ahead and finish that up. Notice, okay, a couple pieces here. I failed to reject the null. So I don't have enough evidence to suggest that it's greater than the national average. Where does that part come from? It's greater than the national average. Is that the null or is that the alternative? This is actually the alternative. You're always stating the alternative, the HA, okay, in your null. Whether you're rejecting or you're failing to reject, you actually state it both times, okay? So the only thing that would change if we had rejected was we would change our p-value is less than or equal to alpha, so we reject, and we say we have sufficient evidence to suggest blah, 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 the rest of it. It all stays the same, okay? So there's very minor changes to your sentence structure, whether you're failing to reject or you are rejecting. Okay, so here we go. Example 6. The company medical director institutes a health promotional campaign to encourage employees to exercise more and eat a healthier diet. One measure of the effectiveness of such a program is the drop in blood pressure. The director chooses a random sample of 50 employees. Okay, so this is good for us. Random sample of 50 employees and compares this blood pressure from physical exams given before the campaign. Okay, and again a year later. Do we recognize the situation before and after? We'll talk about that in a second. The mean change, okay, in systolic blood pressure from these 50 employees is -6. We take the population standard deviation to be 2. The director decides to use it. Oh, sorry, the standard deviation is 20. Mine was cut off. The director decides to use an alpha level of 0.05. Okay, so do you notice the situation we have here is it's a before and after kind of situation. So if the campaign was not useful at all, you would think that their blood pressures would basically be the same. Does that make sense? Before the campaign and after the campaign, a year later, if it wasn't helpful, their blood pressure should still be about the same. So if the campaign is not helpful, on average, where do you think the mean difference would be? It would be 0. So in this kind of a problem, they don't give us a population mean per se, but what we're saying is that the null is that our mean would still equal 0. But what we want to show is that the way they subtracted, they did the subtraction here is after minus before, so you're getting like a negative number. So we want to show that the mean is less than 0. Okay, so we want to just define our mu is the average difference in blood pressure before and after the campaign. The promotional health campaign. This part where you define what your variable is, they look for on the AP exam. So they want you to define it. Okay, so it doesn't have to be, you just take it from the context of the problem, but it needs to be on your paper. Okay, next up we've got our conditions. Okay, simple random sample, approximately normal. Simple random sample, do we have that? Yeah, he said that he chooses a random sample of 50 employees. Perfect. Okay, so stated that they selected a random sample of 50 employees. Okay. Second condition, approximately normal. So how are we getting that here? We like this. Our sample size is 50, so we're going to use CLT. So we can say the sampling distribution of employee blood pressures is approximately normal since lowercase n is greater than 30 by the CLT. Notice they have context in both of those statements. We need to work on that, get better at that. Okay, next step is the test statistic. Okay, we're just going to calculate a z-score off this. Okay, so our z-score is our sample value, so minus 6 minus the 0. The population mean is just supposed to be 0 if it wasn't effective. Our standard deviation is 20 divided by square root of n. Okay, so go ahead and calculate that. So you should get negative 2.12. Okay, the next thing we have to do is find how likely is that to occur. Oh, I'm running out of room, so I'm going to do my p-value over here. Okay, so I want to find the probability. And again, you can write either the x bar, in this case, is going to be less than negative 6, or the probability z is less than negative 2.121. You don't have to write both. I'm just writing both right now. You can just choose one. Okay. We're going to do normal CDF, negative infinity up to negative 2.121. Draw my curve on here. All right, when you calculate this, it's going to be 0.017. Okay, depending on how many decimal places you use, but it should be close. We're going to compare this. We're comparing it to an alpha level. When we look back up here, so we're using an alpha 0.05 significance level. Okay, so when we compare our p-value, is that less than or equal to alpha 0.05? So our p-value is 0.017. Is that less than or equal to 0.05? And again, if you struggle with decimals, comparing them in your head, just multiply it by 10 or 100 to move the decimal place so that it's easier to view. So like 1.7, is that less than 5? Yes. Okay, so we're going to decide to reject. So our conclusion is that since our p-value is less than or equal to alpha of 0.05, we're going to reject the null. So there is sufficient evidence to suggest that the mean difference in blood pressure, we can basically say after, because we're doing it before and after, is lower than before. Okay. The mean difference in blood pressure after the exercise or fitness, what are we talking about here? Health promotional campaign, whatever, the exercise campaign. Is lower than before. Okay. That's saying we have a mean less than 0. That's all it's saying. That's the alternative hypothesis. Okay, so the alternative, the mean is less than 0. So I'm saying that when you look at how we subtracted, it's lower than before, so we're getting negative numbers. It's just less than 0. Okay, let's go through, we're going to go through, I think, one more here. All right, so example 7, a local school board member wants to know if sophomore students at Lincoln High School have a higher reading level than the state average for 10th graders. The state average is 150 words per minute with a standard deviation of 15. The significance level of the test is to be 0.05. A random sample of 100 10th graders has been drawn, and the resulting average is 157 words per minute. Conduct a test of significance to determine if the sophomore students at Lincoln High School have a higher reading level than the state average for 10th graders. Okay, so the state average, so this is our population mean, is 150 words per minute, and a standard deviation of 15. So that's our population values. They tell us that alpha is supposed to be they want to test it at 0.05. That's information we know. So now when we start talking about our sample, we've got our random sample is of 100 10th graders. The resulting average from that sample, so this is our sample average, is 157 words per minute. And then it says we want to carry out a test of significance to determine if the sophomore students have a higher reading level than the state average. So that tells us our alternative hypothesis. All right, so mu is equal to, and let's go ahead and define mu. I don't think I did that in the first problem, but let's define mu. Mu, because again, they look for this on the AP exam, is the state average reading level for 10th graders. Okay. All right, so our null is that the mean is the same as what they claim. So it's 150. And the alternative, they want to see if they can see if it's greater than. They have a higher average than 150. So we're going to look at our conditions. Okay, again, our simple random sample and approximately normal. They gave us that they took a random sample of 100 10th graders, so that's good. Okay, so they stated that they used a random sample of 100 10th graders. Okay, so we get our simple random sample. It's approximately normal again by CLT. Okay. So the distribution of 10th grade reading levels is approximately normal since lowercase n is greater than 30 by the CLT. Okay, so now we get to our test statistic. Again, we know the population standard deviation, so this is going to be a Z test statistic. I take the sample mean, which is 157, minus the population mean of 150. I'm going to take the standard deviation 15 and divide by square root of 100, square root of n. So go ahead and calculate that. All right, so you should get 4.667. So that's a pretty large z-score. So if we have large z-scores, what's going to happen to our p-values? They get very small. Okay, so I'm going to do our p-value over here. So the probability that my z is greater than 4.667. You could write same thing, x bar is greater than 157. Okay. Normal CDF, 4.667 to positive infinity. Draw my curve over here. Tiny little bit shaded in. This should be very small. So you should get 1.507 times 10 to the negative 6. So there's 5 zeros in front of that 1. So it's very, very small. So if we compare that to our p-value, less than or equal to alpha. So 1.507 times 10 to the negative 6. Is that less than or equal to our alpha level 0.05? Yeah, it's definitely small. So we're choosing to reject. So since our p-value is less than or equal to alpha, which was 0.05, we reject the null. Okay, there is sufficient evidence to suggest that the sophomore students or the 10th grade students at this school, so at Lincoln High School, have a higher reading level than the state average of 150 words per minute. Okay, one thing I want to point out is in my sentence when I'm writing it, notice that I always have been writing, I have evidence to suggest. I'm making a suggestion. I do not want you to use the words prove. Don't use that word. We're not proving anything because if we took a different sample, we could get a different result. Say we haven't proved it. We're making a suggestion based off of the data we have in front of us. That's it. We're making a suggestion. We don't prove anything here. Okay, so just watch out for that. That we don't use the language prove. We're just making suggestions. All right, thanks so much, you guys. Bye.